All right, what's up, and welcome back to Grain Sessions episode 6, I guess. Today, I, I'm going to be talking for a few minutes at a Cycloche community meetup in a bit, and I just wanted to prepare for that. And then I also wanted to start developing, um, start developing the framework and ideas for the Grain Talk. Um, the Grain Talk, which will not be happening at Conj because the proposal was rejected, but I think that's just convinced me even more that I should still try to develop one. It's a tricky subject to cover because Grain is an assembly of ideas that, when manifested into something executable, it solves a whole lot of problems with all of this AI development stuff, and even like before AI development. And so it's much like Clojure in that sense that it has so many good qualities to it that it's really difficult to explain the whole at once in one sitting. And um, it tends to be a bit of an information iceberg that it's really unfortunate to have to drop on someone. And so I've been trying to figure out ways of not dropping that iceberg on people. And so I think that naturally leads to asking the question of like, what is the tip of the iceberg? Um, of course, the tip of the iceberg is always going to be a bit sparse. It's not going to give you all the information. It should lead to additional questions that where the answers live underneath the surface of the water. So just turn my music down a bit in my headphones here. So let's actually run through. let's actually run through what I'm going to present at Cycloche. I probably have 5 to 7 minutes, and I'm doing an experiment this time of like, what happens if I really don't give any technical detail? And the theme of this meetup is just sort of what have we been working on, and so, what have I been working on, minus all of the extra information. And if people have questions or want to follow up later, that's what the links in the slides are for. So I'll just use this opportunity to practice. Hey everyone, thanks for giving me the time to speak. My name is Cameron Barre. I'm CTO at Omni AI, and we're effectively a software or an AI platform company masquerading as a consultancy. So we're really focused on investing in our own tooling, owning the entire stack for software development and AI assisted development. And then we use our uh, customer relationships to battle test our tools and build software with AI that we can actually take accountability for. And so, what I've been working on, what we've been working on, the problem that we're trying to solve is kind of captured in this statement, which hopefully should resonate with a lot of people right now. And that is, I can produce a lot of code at a high speed, but over time, what I produce ends up drifting. So that when I look under the hood, I do not understand what I'm looking at, and I cannot take accountability for this kind of work. This is personally very important to me. I actually refuse to take accountability over AI generated work that I do not understand at the end of the day. Not in my personal projects, not nothing like that, but when it comes to like actual production code that I am accountable for. So without a solution to this, uh, I would not even do AI assisted development. So, but we have solved this problem at our company, and looking forward to sharing with you sort of the ideas behind that. So, conversations about AI assisted development tend to get murky because there's different ways to use AI in software development, and there's also a lot of different kinds of software that we build. And so I'm going to just situate us so that we can be specific about what we're talking about so that you know how to interpret what I'm saying. So there's at least two ways to build software with AI. One, uh, build non-AI software with AI. That means produce like conventional information systems faster than ever before. But those information systems may not have anything to do with AI in terms of features. And then the other avenue is build AI features into software. So we've actually solved both of these problems, but I'm only talking about the one on the left today, which is build non-AI software with AI. If you're interested in either of these, there's links to the repositories in the slide here. All of our work is fully open source, not to try to convince anyone that our way is the best way or that they need to use it to be successful. Uh, what we've done is assembled good ideas and made them executable, and we think that anyone can learn to do it themselves if they know what they're looking for. So we're talking about just building software. What type of software? Well, this is another problem in conversations about AI. Um, we never or rarely today actually specify the kind of software that we're talking about. Us developers, we make a lot of different kinds of things, ranging from languages, libraries, frameworks, information systems, embedded systems, and more. And so we really need to be specific about what kind of software we're talking about solving problems for, because different software is going to have different tolerances for the kinds of dimensions that we're trying to solve for and that we care about. And so my line of work is specifically about information systems, production apps that live for a long time that someone has to be accountable for, and where architectural drift causes problems and wastes money. And so that's what I'm talking about today. I'm talking about solving the problem of accountability when producing information systems with AI. Over on the left side of the spectrum here, we have this idea that novelty behind a contract can be fun. When you have something that is like a language or a library or a framework that just needs to meet a certain kind of contract for the consumer, things that happen behind that contract or novel and interesting ways to combine those contracts, that can be a lot of fun. That's what makes developing those kind of solutions fun. But on the right end of the spectrum, novelty causes problems. I do not want uh, the way that my information systems are built on a day-to-day basis to change really ever after I've sort of set the paradigm in place. And it's the novelty that creeps into workflows and solutions underneath intent uh, becoming code that causes drift and causes the problem statement in the first place. It's not the only thing, but it's a major factor. So I'm specifically talking to you about information systems today, and then so how do we solve this problem? We solve this problem with our Grain library. Um, Whether it's a library or a framework or something else, it is up for debate. You can build a whole company on top of it. So, but basically, Grain enforces a uniform architecture. And what that means is that it makes it impossible for AI coding agents, when used in the right way, to actually uh, take novel approaches to building your system. Um, and what this results in is one architecture paradigm all the way down. Grain is a CQRS and event sourcing framework, essentially. So if it's not a command, a query, a read model, a reactive processor, a periodic task, a schema, an event, then it's simply wrong. So it's one architectural paradigm all the way down. There's only one correct way to assemble an information system out of these primitives. And that was a challenge that we had to solve, is making sure that the primitives that we do allow for are expressive enough to make any kind of information system that we need in our line of work. Grain allows for minimal surprise when I look under the hood. Um, Whether it's 6 months from now, 12 months from now, a year and a half from now, whatever, when I look under the hood, the architecture paradigm will be uniform. There will only be the primitives that I expect to see. So that leaves zero room for architectural novelty. And this is a system that I can take accountability for over a long time horizon because regardless of where the product or domain goes, the how the product and domain is implemented is uniform and does not change from development cycle to development cycle. This is something that people are still trying to solve with spec-driven development, skills, increasingly complex systems of markdown instructions. But anything that comes to a coding agent as an instruction is not something that can bottom out its decision making in a constrained way. Grain is a framework, but it's a highly opinionated framework in the sense that it uh, most frameworks today, Rails, Django, you name it, whatever framework you want to go with, they're so general purpose that there's like a million ways to do everything correctly. Well, that's what AI has been trained on, and so it when you give something that is so probabilistic, all of that free range to operate, it's going to choose different ways of doing things over time, regardless of what your spec says. There's nothing to actually bottom it out if you're only giving it instructions. And so, what Grain is, it's a highly, highly opinionated framework for building information systems, but it's almost sort of like a compiler for information systems as well. It's almost a substrate that sits underneath the intent, like the process of turning intent into executable code, um, such that you can be sure of the architecture model that the executable code will have. So, what does Grain not do? Grain doesn't solve for product or domain drift. It eliminates architecture drift as an error category. This is a prereq for doing spec-driven development in an effective way. Specs can't prevent this drift, like I just said. So, like, we have nothing against spec-driven development, any of it. But we do think that there are two sides of the coin, and you can live without one side of that coin. Like you can survive without it. That's the spec-driven development side. You can't live without the side of the coin that constrains your architecture to a uniform model. You can go a long way with just that side, and then you can start to reap the benefits of spec-driven development with the other side of the coin once you have that in place. If you don't have that in place, then you'll always be at risk of architecture churn and drift, which gives everyone that frustrating feeling of like, yes, this was going so well at first, but then it fell apart and I don't actually understand how this thing is built anymore, so I can't be responsible for it. So, how should you think about this problem? There's a pretty good paper called CODA's Agent Harness, kind of like all of the big people in the industry came together to make it, I suppose. And the what it did for me is it gave me a mental model to sort of like decompose the space of what it even means to work with agents on software. And the three sort of dimensions that it breaks this problem into is over here on the right, model internal capabilities, system supplied infrastructure, and agent initiated code artifacts. Model internal capabilities is something that most of the time we have very little control over. Maybe as things progress and we mature in this technique, in this paradigm, we start to have more control. But I'm just thinking big picture, like frontier models right now. So, model internal capabilities, this is just how good is the model that you're using. System supplied infrastructure, I don't think a lot of people are thinking about this in a decomposed way, but we should be. On the left here, you see all the coding harnesses that you're probably familiar with, like Codex, Claude Code, OpenCode, Pi, Dirge. Um, these, paired with a capable model, makes for a competent harness experience. Okay. But on the other side, there's also a side of the harness system that is skills, instructions, and then notably here, grain. So you can think about uh, that we're composing grain kind of as a tool for these competent harnesses um, to use to produce software. So by combining these two things, we get a reliable tool and substrate for actually taking intent and turning it into executable code. Then what that leads to is a Grain app as an agent-initiated code artifact. So the app that actually gets produced is an artifact that agents, any combination of competent harnesses and capable models and sets of skills and instructions, can come back to this artifact and continue to work on it. And the viability of working with that artifact hopefully remains consistent and constant, because of the way that Grain apps in this case are extremely simplified, and and the all of the ideas that go into Grain and why it works makes for an artifact that doesn't devolve into chaos over time but remains consistently workable. And so that's all I have to share today. Um, this may have left more questions than uh, raised more questions than it answered, but I think that's what happens when you kind of stick to the tip of the iceberg. If there are more questions, happy to answer them, and I can share the slides, and they have the links to everything. Oh, okay. So that was like possibly 15 minutes. And I think I spent too much time. This slide was a little meandering, and this slide is a little meandering as well in how I approached it. Okay, so moving on. Well, checking messages. Okay, so moving on about like what a talk about Grain and the problems it solves, what a talk would be like. I think it maybe starts similar to the small one here. It has to find a way to communicate this idea of shallow substrate versus no substrate at all, no bottoming out of decision making, and how this naturally is going to create more drift. So what's the move here? We could try to establish a timeline. So we got our timeline here. And I think that certainly we introduce the problem statement. Well, okay. Who am I? So first, who am I? Second, there's a problem statement. And the problem statement should probably be very similar to this. It's got to be something that anyone listening, or maybe in an audience in a hypothetical world where I'm actually giving this talk in person, it needs to resonate with them. And I don't think that's too difficult because the whole industry is currently struggling with this problem of um, trying to get the best use out of all this AI technology. And really what it does is it allows you to automate labor. So it's like you're getting production speed increase. But the caveat is that if you don't have the right foundation, what ends up happening is that you probably lose speed, or you're very uncomfortable, because you don't understand what it is you're producing. So there's the problem statement. Um, so another aspect of this talk is that it's going to be about more about ideas that make all of this work than the actual tools themselves. So we have the problem statement. I think we're going to want to situate ourselves. So I think this model here is good. Like This is the problem statement. This is situating ourselves, what we're actually talking about. We're building software, and that software is information systems. So situate. Then after we situate, I'm gonna have to go into more details than this. I can't just drop the solution description of the solution in a 30 or 40-minute talk. So problem statement. Oops, I have problem statement twice. So we have introduction, problem statement, situate. And when we're situating, we're defining, maybe we're defining terms, maybe um, we're defining terms, we're discussing what we are, or we're defining what we are and are not talking about. We're showing that there's other things that we could talk about that we're not going to talk about in this particular talk. And after situating, we have to start building up the ideas that are going to make things work. And when I think about the bottom the bottom floor of what makes everything to do with grain work, it's um, it's really about constraints, assumptions, and constraints, assumptions, and the free lunches, we'll say, that come from the combination of those constraints and assumptions. So introduction, problem statement, we situate, we start to lead into the solution. At the bottom floor of that solution is constraints, assumptions, and the free lunches that we hope to gain from those. I think that I do think some of this would be controversial. I mean, again, we're not saying that the way that we've figured out how to solve for this is the only or the best way. It's just the way that works for us aesthetically and stylistically. And so anyone who understands all of this can go and do it themselves. So the question is, how detailed do constraints and assumptions get in this section? Like, in my mind, it's an assumption that the database paradigm will be immutable and event sourced. So I wonder if this is the place to discuss that in detail or not. I mean, this could just be like a larger section, so maybe under the timeline we can start to try to list out what might be covered here. So here it's kind of like, why is this so? I don't know what this button even does. Okay. Oh wait, I do want that. Okay, so we got who am I? What I do? What I'm interested in. That's an odd way to, like, what? Okay. Oh, okay, maybe we just also need to do alignment. Yeah. So who am I? What I do? What I'm interested in? Messages. Okay. So the problem statement is to boil it down, AI generated systems tend to fall apart and become slop that can't be maintained. That is the main problem statement, and the main thing that myself, as a leaned-in skeptic of this technology, everyone has to contend with this. Where everyone's being told, like, hey, you can use AI to do all of this cool stuff, but then everyone's also experiencing that there's something missing. Okay. So situating, we define things. So we might define AI native. I think it might come into play. We might define uh, the ways of building, ways of using AI. Might define what kinds of software we make as developers, and specifically the kind of software this talk is about. So maybe there's more in there in the end, but that'll do for now. Now, with this one, maybe we can just start by, and maybe some of this we end up editing out. So free lunches. I feel like free lunches is maybe an implication. I think free lunches is an implication of these constraints and these assumptions. So the constraints are pretty minimal, actually. So we have a command query read model to do processor periodic task. That's 5. Schemas and events. That's a little loose, but that's roughly 7 primitives. So the constraints are that information systems be built with only 7 primitives. The assumptions are that database paradigm is immutable and importantly, database, let's see, database paradigm is immutable and event sourced. The reason I'm saying immutable and event sourced is because there are ways to do database. There are techniques for databases that are immutable but that are not event sourced. I think that the event sourcing is really important for the flexibility. I've seen people use immutable databases like Datomic in a more conventional way that causes a loss in flexibility over time, despite the fact that it never forgets anything or it never forgets some things. So there's it with Datomic and like if you're not doing event sourcing, then you have to really think about what you're doing a lot harder. And I'm trying to avoid having to think harder. So if you're using event sourcing, it kind of sets you up to defer lots of decisions till later because you know that as long as you're capturing the data you need to capture, then you can do a lot with that. Okay, so if we have, I mean, is that really all the constraints and assumptions? The constraints are information systems can be built with only 7 primitives. The assumptions are a database paradigm that is immutable and event sourced. When I think about it, I think about there being a lot more than that. Or like it seems like there's a lot more than that, but that is kind of that is kind of it at the end of the day. Uh, yeah, I think that actually is a point in favor of it's a point in favor of just with if we can do a lot with just these minimal constraints and assumptions, think about how much more we could do if we kept building on that tower of abstraction, introducing higher level constraints and higher level assumptions, which is exactly what that is exactly what Orc is. Orc is an information system for agents and agentic features and software built up on the assumptions of and constraints of Grain. And Grain has big ideas, but Orc has even bigger ideas. And then the things that you could build on top of Orc, like agent harnesses and things like that, could have even bigger ideas. And that all sort of manifests upwards from the bedrock constraints and assumptions. Hmm. I think from here the primitives we could explain the primitives. Can I have my like normal spacing? There we go. So now we have the primitives. I'm listening to music in my headphones, but I don't know yet if people like listen to these on 2 times speed or not. Because if you do listen to it on 2 times speed, then that would make the music sound really funny. I did one episode where I had music playing, but okay. So the primitives are commands, queries, read models, processors. We call them to do processors and event modeling. I might not call them that for the talk. Periodic tasks, schemas for all these things, and events. I'm not yet sure that I consider schemas a primitive. Well, actually, I do. Everything listed here, ironically, except for events, which I might change soon, has a macro in Grain to make them and register them. And I think events might actually be a missing element in there, even though they're like so fundamental to the system and you obviously can't do anything without them. Um, there should probably be a registry of events that is not just a the universe of schemas that are event schemas. And the reason is that I think there's a near future where I enhance all of these primitives explicit connections to each other that helps actually map them onto like a event model specification. And I think that I may need all of them to have a macro and be registered somewhere and talk about who reads and writes what and stuff like that to really make it all work in the end. So that I think it's possible to have a conversation about these primitives without getting overly technical and specific. Beyond mentioning like here's how we do it, and Grain we have a macro for all of these things. Okay, so we have the primitives. I think we then need to detail how it all factors into the event sourcing paradigm. And maybe that would cover like the event store protocol API. So like we have read, we have append, we have, what else do we have? I mean, it's intentionally slim. So let's go see event store v3 protocol. So we have append and read, and then the ability to get information about tenants, which I probably wouldn't even talk about. So everything that we do in Grain is really like the event sourcing part of this with the read and append protocol is like the sun of the solar system, and everything else is just orbiting around it. Yes, and then let me lock the timeline here. And then I think what we're approaching here, what we're building up to. So we're building up from introduction, problem statement, situation, constraints and assumptions that make all this work, the primitives that then uh, carry out those constraints and assumptions, how it interacts with the sort of center of gravity of it all, which is just the event store API. And then, yeah, because I think something that's challenging people right now, basically, is that this is not just the way to make all this AI stuff work is not just a oops, my music. Is not just a coding thing. It's a whole system holistic thing. It's a like the database paradigm that you're using with your code matters for how flexible your system can be when you have code harnesses automating the work on the systems. It has major implications whether you have a 200 plus table relational schema that's point in time and lossy versus you're using Datomic, but you're kind of using it from an entity first perspective versus you're using event sourcing where you're saying, all I know and care about is what happened, and I'll figure out how to have different perspectives on that later, and entities and stuff will emerge from that. All of this matters with how it's all connected to how the coding agents work with the uh, the artifact, the system. Because remember, back to code as agent harness paper, model internal capabilities, system supplied infrastructure, agent initiated code artifacts. Grain is like a tool in the hands of these competent harness model combinations, plus human possibly steering. Grain plus skills. I call this the instructional part of the harness. So I call it the instructional harness. Grain is a substrate that takes the intent and becomes an executable agent initiated code artifact. And that code artifact's ability to stay simple and organized over time, and most importantly, tolerant of change, because all software changes. That's what causes all these problems in the world of software development. So being able to be flexible being able to be situated from the start because of the constraints and assumptions to be flexible over time is what makes Grain a good agent-initiated code artifact, because the CQRS and event source domain kind of creates like a domain-specific language out of the commands and the events, and how they speak about what's possible in the product. Read models and entities can come in and out of fashion as things change, but the artifact itself maintains a cohesive and coherent uniform model so that long into the future, anytime you have to come back to something with one of these code agents, you have your instructional harness and you have Grain, and it uses that to manage and manipulate a Grain app, which is an agent-initiated code artifact that's meant to live for a long time. That's why you can survive without a spec when you use Grain. I'm not saying you should never have a spec. I think specs are super important. They specs address drift at the product and domain level. Grain addresses drift at the software architecture level. Two complementary levels. So maybe that is yeah, I think after that, so we have an example of a Grain app. So we have an example app, which we do have something to point to that we could refine leading up to giving a talk like this. It's Grain to-do list. And I think I could actually talk about the example app without really doing a lot of code showing off. Like, because of the CQRS primitives, the commands, the events, the read models, it's all there already. You could probably make a pretty compelling diagram or something, and get the point across that way. And after having the example app, honestly, example app number one, and then I think there's example app number two, because Orc itself is a Grain application. Orc is an information system. Orc is the acknowledgement and the realization that agentic software, like agents, yes, agentic software at its core has its own information system domain. Agentic workflows need to be able to automatically evolve over time. You need to be able to judge. You need to be able to keep track of tracing. It has its own domain. Your product also has a domain. When we fuse these two together, we create a composite domain that's more complex than the sum of its parts. We blend these two domains together, and that's when we get our interesting agentic software that is kind of product and AI capability. And so Orc is just an information system without a UI. It's headless, but you could build a UI for it. It's made out of Grain, and that allows you to pull it into any Grain application as a library. That's a little bit less relevant. That's actually just a free lunch. The composability of Grain applications and components and pieces and parts together is an example of a free lunch. So there are free lunches to talk about. Okay, I think after the example app, it would probably make sense to put like to talk about this. Um, the code as agent harness model, where we would talk about model, internal capabilities, system supplied infrastructure, and code agent initiated code artifacts. Okay. And then we could talk about free lunches maybe. And I need to think about this one a little bit more, but we'll put on there composability, compound engineering, and there's definitely more that we can focus on. Okay, I mean, even just this alone, so if we had 40 minutes, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which is completely insane, but that gives like 4 minutes per topic here. And so maybe some of these wouldn't take a whole 4 minutes, and we could like weight the. We could probably intuitively figure out which of these should be weighted heavier. Um, that being said, if I'm not constrained to a conference, like a literal physical conference talk, I could make the talk as long as I want. It could be an hour and 45 minutes if I want it to be, which is probably something to consider actually. And then if I ever had to give that talk somewhere, I could tone it down. But the real source of the information uh, could be much longer, and I think that would actually probably be for the best. So it's more like, let's say I have 60 minutes. Let's just say 2 hours. 2 hours, so 120 minutes divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That would give me 12 minutes per section, and even that, again, that would probably be weighted differently. Probably a decent amount of time spent talking about these, and everything else is probably a bit more minimal. Okay. All right. I think that is going to be it for Green Sessions episode 6, which I guess we did actually do this. What color is this? I can't tell. Oh, wait, I can't tell. Boom. I mean, I think there's more to flesh out here, for sure. But we did get to that. We'll have to think about this. I do have some ideas. Oh yeah, I remember what I was thinking with this. I was thinking about like maybe taking the to-do list app and turning it into something like Posthog. Oh, come on. Where's the Yeah, let's go here. Oh wait, no, that's not what I want. Where's the you know how they have the like desktop? I think one day I clicked like go to the website version, and now I'm just stuck on the website version of their thing. Deskhog? No. Posthog desktop app. No, I don't want a desktop app. What am I thinking of? This. If they're gonna make it hard to freaking get there, then we'll just look at it in an image. I think it might be cool to take the to-do list app in the direction of a more complex desktop app experience where the note-taking part would be, or the to-do list tracking part would be just one sort of app in the grand scheme of things. So I think that's coming eventually. We will work on that eventually, but we'll probably end up circling back to. Oh, that's not good. We'll probably end up circling back to the grain talk development. Yeah. All right. Well, if you've actually watched this or listened to this, thanks. Remember, you could always join the grain channel in the Clojure Slack if you do want to participate. You could also direct message me on Slack. A couple people have been doing that lately. Happy to answer any questions and help you experience these ideas so that you can decide whether they're worth your time as things just get crazier and crazier. All right. Uh, See you next time.